All right, so this is the second example for day 33. Okay, and same thing. We're just going to do it exactly the same as the last one, but it's, just a different example. Okay, all right, so if 8.4 moles of C4H8 react with O2, how many moles of H2O are produced? Okay, all right, let's see if this one will balance. Okay. All right, so C4H8, so whenever you see these combustion reactions, okay, hopefully you're recognizing this as combustion, okay, you want to balance it CHO. In that order makes it a little bit easier, okay? So here I can see I have 4 carbons over here and only 1 over here, so I'm going to try a 4 here. Okay, now let's do the H's. So I see 8 H's over here and 2 H's over here. Okay, so let's try a 4 here, okay? And then over here now I'm going to see 4 oxygens and 8 oxygens for a total of 12. So that means I have to put a 6 here, and that's going to get a 1, okay? All right, so that has to balance first. So that's all set. Let's see, 12, 4, 8, yeah, 4, 4, 4. Okay, all right, now we have to go to the problem. So my given is 8.4 moles of C4H8, okay? So here in the before, we're going to put 8.4 because that's what's given. All right. And then I'm going to use that whole 8.4 to leave me with nothing. Okay. We're assuming that the reaction is going to completely use up this C4H8 fuel. Okay. All right. Remember your change line, okay, is the one that is the important one. Okay. So I'm going to carry across this 8.4 because everything is going to be based on that amount. Okay, and then I'm going to put my ratios. Okay. All right. Okay, so the given is this one. Okay, so that's why that's going to carry across in the change line. So now I have to do the ratios. All right. So remember, the 8.4 is moles of C4H8. So that's what's going to have to go on the bottom. So your given coefficient always is the one that goes on the bottom. Okay, then you're just going to carry across or carry down these coefficients from the top. So 6, 4, 4. Okay, right? Because the reason why you're doing that, well, here, I'll do it this way. Okay, so 8.4 times 6, 4 times 6 is 50.4. Wow, that's a lot. Okay, is 50.4 that you're losing, which means I had to start with 50.4. Okay, and so remember, conceptually, you want to be thinking about that, right? For every one of these, I need 6 of these, right? So you want to think like that's going to be a much bigger number because in effect, what you're doing is multiplying by 6, right? Because for every 1 C4H8, you need 6 times as much oxygen. Okay, so that's how you got 8.4 times 6, okay? And then you would be left with 0. Okay, same thing here. If you notice, if one of these, I need 4 of these and 4 of these. So that's also going to be a much bigger number. All right, so here, 8.4 times 4 is 33.6. Same thing here, 33.6, because that's the same amount. Okay, remember your products are going to start with nothing because the reaction hasn't happened yet. The change amount is going to be an addition of 33.6 moles. Okay, right? Because there's only one of these and it requires so much more. That's why these other numbers are so much bigger. Okay, all right, so the word equation, you're going to start with 8.4 moles. Okay, and if you don't know the name of C4H8, you can either look it up, okay, or if you, for these ones, if you want, you can just say hydrocarbon, fuel, or fuel is fine too at this point, right? Okay, combines with 50.4 moles of oxygen, okay, to form 33.6 moles of water and 33.6 moles of carbon dioxide. Okay. All right. Okay, so that's the old part. Now we have to add this new step of figuring out the mass, okay? So what mass of water was produced, okay? Well, we can see that we produced 33.6 moles of water. Now I'm just going to multiply by the molar mass to turn that into mass, okay? So the molar mass of water, okay, again, if you want to Just look it up. That's okay, as long as you know how to solve it. Okay, so I have 2 H's and 1 O. Okay, so remember, I'm getting those off the periodic table. Okay, you might have even memorized water by now because it's pretty common, 18.02 grams per mole. Okay, so since I have moles of water here on the top, I want to put 1 mole of water at the bottom. Okay, it's always per 1 mole, right? And then 18.02 grams of water at the top. Cancel that out. Multiply. 605.5 grams of water. Okay. All right. I can do this with any number of things. So for the reaction to have the perfect proportions, right, meaning I would run out of both of them at exactly the same time, which for now, that's what we'll be doing. What mass of oxygen is needed? Okay, so if I look back at my table, I can see that I needed 50.4, right, moles of oxygen. So I can start with that. 50.4 moles of O2, okay, times O2, right, is just 2 times 16, which is 32 grams per mole. So 32 grams of O2 in 1 mole of O2. Okay, and then that's going to cancel. And then I'm going to multiply and get 1612.8 grams of O2. Okay, good. All right. Okay, so the next one, I want you to try this one. So if you're working through this right now, what I would do is stop the video, work through this one yourself, try to do it all by yourself, see how it goes, then check the answer key that I provided, okay? Because then you'll know if you're getting it right, and then I'm going to give you one more video of a slightly different way to do it, and then you'll just work the rest.